All right, we're going to jump right in it. This is the characteristics of quadratics part 2. Last class, we did the k, and if we're paying attention on the last class, the k value, if it said x squared plus 2 or x squared minus 5, the k value told us to move the parabola either up or down. If it was a positive k, we moved the parabola up that many units. If it was a negative k, we moved that parabola down x many units. Now we're going to go ahead and add in what this h does for us. And also take note, it says x minus h, so we got to be very leery of what happens here and how these two work together. Let's first take a look at the problem. And I'm going to go ahead and go to my calc. I want to type in exactly how I see it. Parentheses, x minus 2, close parentheses, squared, plus 1. Now, we should know what this plus 1 does. This is my k value. This is my h. This is my k. And I know that my k value from last class is that my parabola should move up 1 unit. So we're going to graph this, and after it goes up 1 unit, then we see what this has an effect on it. Graph. Got a slight glare there. Okay. So it still went up 1 unit off the origin, but it also went to the right 2 units to the right. So it looks like h is affecting our left to right. And once again, take note, it says x minus 2. H is going to be the opposite. So really, this subtraction tells us to go right. So I'll go up 1, right 2. Okay, let's go to the second table. Let's go and fill in the table, fill in this data, and make sure you do it accordingly. We start off at -1, not -3 like last class, and fill in the correct information here. So I have 10, 5, 2, 1, 2, 5, 10. Okay, I'm going to go ahead and plot this on my graph over here. -1, 10. Don't forget now, as soon as I graph this, I need to draw my axis of symmetry, which is always right down the middle of my vertex. Okay, so there's my axis of symmetry. Now, once again, we knew that my k value, so this is my k value, this is my h value. We knew from last class my k value goes up and down. So this would have gone up +1. And from my origin, I went up 1 according to the vertex. Everything's according to the vertex here. I went from my origin, I went up 1. But I also went to the right 1, 2. So it looks like h, if we subtract a value, we're going to the right. And then I'm willing to bet that if we add something, we're going to end up going to the left. So for transformation-wise, from the origin, the parent function, we go up 1, right 2. So I'm going to go ahead and skip down here and go up 1, right 2. That's my transformation. Now let's go and fill in the rest of the data. Asking for a 0. I do not cross the x-axis at all, so there would be no 0. Okay. Next, vertex. There's my vertex. My vertex is now has moved. It's now at the point 2, 1. My y-intercept is located over here, which is at 0, 5. Okay, matter of fact, I'm going to go ahead and write on this to make sure we're very clear. That's my vertex. This is my axis of symmetry. This is my y-intercept. There it is. And my vertex is a minimum. Okay. Now, axis of symmetry, it's always going to be the h value of the vertex. So this one gets copied down here, x equals 2. My k value is positive 1. And it's asking you again what the value of h is, but just make sure we understand that this is h. It's repetitive. H goes here, H goes here, and we're going to say what H is here. Make sure we all know where it's at. I take a look at my domain and range. Domain for all parabolas. The minimum is negative infinity. The maximum is positive infinity. That does not change for us. Negative infinity is less than x is less than positive infinity. My range does. My vertex affects my range. The lowest value on the y-axis is positive 1 included, and it goes all the way up to infinity. So my range is going to be positive 1 is less than or equal to y is less than infinity. So number 2. Okay, I got my equation. Here is my h. Do this in red pen. Here's my h. Here's my k. Now, let's just go and take a guess. K is negative. So from day 1, when k was negative, we said we go down 3. Now, last problem, we had subtract 2, and we went to the right. Now, h is plus 1. Go ahead and take a guess at what plus 1 is going to do our parabola. So we're going to go down 3, and then something right here. Let's go to the graph. Okay, go to y equals, erase what I have, parentheses, x plus 1, close parentheses squared, minus 3. Okay, so I know I'm going to go down 3. Let's see here. From the vertex, right there, 1, 2, 3. I did go down 3, but this time it looks like I went to the left 1. So last problem, when it said x minus 2, we went to the right 2. Now it says plus 1. I'm going to go left 1 unit. Down 3, left 1. I'm going to go ahead and skip to the bottom here. Down 3, left 1. Okay, I still need to go to the table. Second table. I'm going to start at -4 for my answer. So I need to go up. And at -4, it's positive 6. 1, -2, -3, -2, positive 1, positive 6. Just to make sure, I'm going to just do a test point in there. I'm going to throw in 0. 0 plus 1 is 1. 1 squared is 1. Minus 3 is -2. Okay. So whatever you plug in for x up here should produce this y value. Let's go and plot our points. -4, 6. -3, 1. -2, 2. -1, -3. 0, -2. And I'm going to just kind of mirror this. Okay. This probably also will show a little bit better that from my origin, from my parent function, to get to the new vertex, we went 1, 2, 3 down, which is my k value, minus 3. And we went left 1, which was my h value of plus 1. When it's inside parentheses, we got to think opposite. And it's not natural for us to think a positive going left, but we got to remember that it's going to be opposite inside the parentheses. Okay, don't forget our axis of symmetry. Okay, here's my axis symmetry. So AOS, here's my vertex, here's my y-intercept. Okay, let's go ahead and fill in the data. I'm going to do the zeros last. So my vertex is right here. My vertex is at the point -1, -3. Is a minimum. I'm going to save my zeros for last. My y-intercept is at 0, -2. Axis of symmetry is the same value as your h, which is -1. My k value is -3. H, once again, these are the same thing. These are the same thing here. -1. We already described our transformation. Down 3, left 1. We still have our domain range. Domain is going to be the same thing. My range, the lowest point is my vertex, which is on the y-axis at -3. So -3 is less than or equal to y, which is less than infinity. And I still need to find my zeros. That's okay. I still have my graph here. I know this is one answer and this is one answer. So I'm going to go to second calc 0. Asking if I want to find this answer, left bound would be up here. So I'm going to move my left arrow. Doesn't matter where, somewhere up here. Enter. Right bound would be beneath the x-axis in this particular case. Enter. Take a note. Here goes my two boundaries I set, the two arrows up here. And my x-intercept has to be in between these two arrows you set. It is. So I'm going to hit enter on guess. And it's -2.7, 0. Okay, the parentheses was brought down here. I'm just going to go ahead and put it back up there. And then I still need to find my second 0, my right side. So I need to repeat the same process here. Second calc 0. Left bound, in this case, if this is this answer, left is going to be somewhere down here, left of my answer. I'm going to hit enter. Right bound is going to be somewhere right of my answer. Once again, here goes these two arrows I got set. This one's hard to tell. There's an arrow there, and in between these two is my x-intercept. It exists in between. Hit enter for guess, and 0.70. All right, problems 3, 4, 5, and 6 will be for assignment for you to get that done. And then we'll look at the solutions the following day. Make sure you have both packets ready to go by next class.